So you may have got to a point in your mathematical education in which you're now starting to wonder, what exactly is pi? Maybe you've heard about it from a friend, or you've seen a formula with pi in, but this video is all about getting to the nitty-gritty of what pi actually is and trying to understand it. And as you probably already know, pi, the number pi, is heavily involved with circles. So I've got a circle here. It's got a diameter of 1, and it's got a radius there of a half of 0.5, and you can see that you've got the circumference, which is the outside length of the circle. And we're going to see whether there's any connection between the diameter of the circle and the circumference. And to do that, I've got a little animation so we can see what the circumference is of this circle if I roll it out. So it's just rolling out there. And for this circle, the circumference looks to be about 3.1. Now I'm not interested in exactly what it is for the minute. I'm more interested in the bottom line. As you saw, when I rolled out that circle, the diameter was rolling out underneath. And it seems as though 1, 2, 3 and a bit diameters fit into the circumference. So this diameter here fits into the circumference 3 and a bit times. And it'll be interesting to see whether that happens in other cases for different circles. So let's change our circle to a diameter of 2, and let's see if the same thing happens in this case. I'll start the animation. So again, I mean, the circumference here looks to be about 6.3, but the most important thing is that the diameter has fit into the circumference 3 and a bit times again. Let's see if that happens for a diameter of 3 units. So I'll start the animation. Fingers crossed. This is looking promising. Brilliant. So the diameter again of this circle has fit into the circumference 3 and a bit times. Now let's make it a bit more accurate. Let's see exactly what those circumferences were, and I've got a table here to show where we have slightly more accurate. Right, okay, so as you can see, for the first example we did, the circle had a diameter of 1, and it has a circumference of 3.14. I was a bit off, I said it was 3.1, so this is a bit more accurate than what I said. And for a diameter of 2, it was 6.28. I think I said 6.3, so I was pretty close. And there you can see for a diameter of 3 and 4 as well. Now, in each one of these cases, to get from the diameter to the circumference, all we seem to be doing is multiplying by 3.14 every time. So take 1, multiply by 3.14, and you get the circumference. Take a diameter of 2, multiply it by 3.14, and again you get the circumference, 6.28. So let's try and put a dot there. There we go. So it seems as though we can write a formula down that the circumference of a circle, C, is equal to 3.14 multiplied by the diameter. Now, I've been a bit sneaky. I've basically only allowed GeoGebra to measure these distances to 2 decimal places. If I'd allowed GeoGebra to measure it to 5 decimal places, let's just see what happens if I'd done that. Then it's much more specific. And what mathematicians started to realize as they started to try and understand this connection between the diameter and the circumference of a circle is that this number isn't just 5 decimal places long, it isn't just 10 decimal places long, but it actually carries on forever. And it's called an irrational number. An irrational number is not only a number that carries on forever, but it carries on forever with no pattern whatsoever. So all of these numbers are just completely random, carrying on forever and ever and ever. And that's what pi is. Pi is 3.1415926 blah blah blah, carrying on forever. So this formula isn't right. This isn't accurate enough. Maybe it would be accurate if you were just trying to get an approximate value for the circumference of a circle, but if we're going to do it completely accurately, then we'll say that circumference is pi times the diameter. Which means that if I divide this equation through by the diameter, then I get that pi is equal to the circumference divided by the diameter. Or in other words, pi is equal to the number of times the diameter goes into the circumference, which is about 1, 2, 3 and a bit, 3.14159, etc, etc, etc. So pi is is how many times the diameter of a circle goes into its circumference. So I hope that's helped you to understand a bit about what pi is, and thanks for listening. Bye.